All right, perfect. All right, we'll go ahead and get started. Hello, everyone, and thank you so much for joining this session. My name is Blerka, and I am with the Gitcoin team. This session will be recorded. Today we have Henry from Moonbeam, who is going to speak about creating Delegation DAO, DApp on Moonbeam through precompile. Feel free to post any questions in the Q&A section, and we'll just try to answer those at the end. So Henry, the stage is yours.
All right, thank you. Let me share my screen first, and I'll start. All right. All right. So, first of all, welcome to our workshop for East Shanghai Hackathon. And the topic for this workshop is going to be about how to use precompiles to create a staking DAO on Moonbeam. Um, So first, allow me to introduce myself first. Uh, my my name is Henry Duong. I joined the Moonbeam DevRel team in the summer of 2021. Prior to that, I work as a software engineer for Microsoft on the Visual Studio team. I first experimented with Ethereum and Solidity in 2016, where I think I created like a very basic like NFT game. Um, so for my for my undergraduate, I studied industrial engineering at UC Berkeley, and I'm currently working toward a master's of science in computer science from Georgia Institute of Technology. I'm currently based in Taipei, but I am originally from Beijing. Um, so before I start the rest of the workshop, let me just like let us take a look at the moonbeam bounties really quickly. And so here's our link, and you can also scan the QR code. And let me just pull up the bounties in my browser. Here. Um, so for this hackathon, we have so for our bounty we have three different challenges, and the first one is to develop a DApp using any Moonbeam precompile, and so this is going to be what this workshop is going to be about. So I will cover this pretty in depth, and will I actually give like a fully functional example. And like the other two challenges, the second challenge is create a tokenized social file or DeFi DApp, and the third one is create any NFT based DApp on Moonbeam. So these two challenges are designed to be fairly open, so that any DApp that uses either NFTs or any kind of social file or DeFi DApp will qualify. So they're pretty much like self-explanatory. And our bounty, our the amount of our bounty is 3,000 USDC, and we will give that to the best Moonbeam project um, from this competition. And also, winning will also give the winning team a fast track to apply for a Moonbeam grant if they wish to continue to work on this in our ecosystem. All right, so let's go back to our slides. Okay, so let me give you guys a quick overview of this workshop. Um, so this workshop is going to be broken up into 4 parts. So the first part, I'm gonna give a quick overview of like what Moonbeam is and how staking works on Moonbeam. And then I will also introduce the concept of precompiles. And then after that, in the third part, sorry. um, yeah, so like in the first two parts, there's gonna be a lot of slides, but we are gonna go through them pretty quickly. They are just to give you some background information so that you can make sense of what we're going to build and why we designed the DAO app a certain way. And then after the first two sections, the meat of the workshop will be on the second half, which will be creating the actual delegation DAO app. We will first go over the smart contracts and the design of the DAO, and then finally we will deploy our contracts as well as a simple UI using Scaffold-ETH. And then at the end, we will do a quick demo of how everything works. So yeah. Okay. So first of all, what is Moonbeam? So Moonbeam is an Ethereum compatible smart contract platform that is built on Polkadot. It is built with a substrate framework, and which means that it has access to all these substrate features, such as customizable runtime and substrate palettes, share security, and connectivity through XCM. So the palette part is sort of the key for our workshop, because we will be interacting with the substrate palette using Solidity smart contract via precompiles. And then the next part is like Web3 RPC support, because Moonbeam is fully compatible with Go Ethereum JSON RPC endpoints. And thirdly, we have like a unified account system, which means that we use the same encryption algorithm and wallet address format as Ethereum, which is the H160 wallet address. This allows a seamless user experience with tooling from the Ethereum ecosystem. And lastly, as I mentioned before, we have full dev tools, and we have a fully Ethereum compatible dev-like environment, and we have we have full integration with Ethereum dev tools, and we will see this in action during the second part of this workshop with Scaffold-ETH. So next, I will give an overview of how staking works on Moonbeam. So before we can talk about staking, we need to have a high-level view of how Moonbeam consensus works, because staking is very closely related to consensus. So Moonbeam uses a proof-of-stake based hybrid consensus. So there are parachain collators who collect transactions, and then they will author blocks. And then we have a consensus mechanism called Nimbus, which is created especially for parachains on Polkadot. And what it does, it will filter the valid authors for each block from the active collator set. And then the blocks are then submitted and finalized by the Polkadot relay chain. So within staking, there are two main roles. One is called collator candidate, and the other one is called delegators. So collator candidate run a collator node, and they can receive votes in the form of delegations. And then delegators provide votes to collator candidates, and they do not have to run a node. So there's a limited number of collators who can be in the active set at any given time. And membership in the collator active set is determined by total bonded, which is equal to self-bond plus the total delegation amount. So we have been expanding the size of the active set over time. When Moonbeam first launched, the active set was only 16, and currently, and we launched at the start of this year, and currently the active set has been raised to 664. And the highest 64 collator candidates by total bond are chosen to be in the active set. And the last thing you kind of need to know is that each collator candidate can have a maximum of 300 effective delegations. So the next thing that you kind of need to know is about how the delegating and revoking works. So when you create a new delegation, or when you want to bond more tokens to an existing delegation, that action is instant. But if you want to revoke a current delegation or bond less, that action is a two-step process. You have to first schedule the action, and then after a certain period of time has passed, you have to execute that action. And if you schedule another action when there is already one in the queue, the old one will be replaced. And which means that one delegator can only have one revoke or bond less action scheduled at any given time. And we can see the graph here that when you want to revoke, you have to schedule the action first, and then you have to wait a certain period of time. On Moonbeam, this is 48 hours, and then after that time has passed, you can carry out the execute action. So this slide is fairly key to why we're going to design our staking DAO a certain way. So keep this information in mind. So now we have a basic understanding of how Moonbeam staking works. The next concept we need to cover is precompiles. So what is a precompile? A precompile is a precompiled piece of code or smart contract. And this concept was originally used by Ethereum for a lot of commonly used like encryption and hashing algorithms, such as SHA-256, RIPE MD56, etc. Precompile is also a type of substrate primitive and is an important part of building cross-chain interactions and interacting with substrate palettes. And the other thing that you need to know is that precompile methods generally skip EVM execution and is computed directly on the local processing node. So what precompiles does Moonbeam have? So these are some of the precompiles that we currently have. We have pair-chain staking, we have pallet democracy, we have XCM transactor and X tokens, author mapping, etc. If you want to see a full list, you can click on the slide, on the link at the bottom of the current slide. So the workshop today The precompile that we will be interacting with is a parachain staking precompile. So next, we're gonna start looking at some code, and here's how you can follow along. So here is the URL to the main GitHub repo for this workshop. So you can click on the link or you can scan the QR code. Let me see if I can show the repo to you guys really quick. Yeah, it should be here. If you scan to the README part, there are a lot of there. I created this section here, which has like the links to basically everything you need to run this workshop yourself. And I also have a link to the slides that I'm currently using. Let's go back to our slides again. So the first smart contract that we will take a look at is the staking interface. So this is gonna be the interface contract of the Moonbeam staking precompile, and which will define how we can interface with the staking palette using using smart contracts. So let me pull up this file. It should be here. All right. All right, let's see. Okay, here. So as you can see here, the staking precompile has methods for both delegators and collators. And today, we're mainly going to be using the methods that are for delegators. And let's look at one of the main methods that we're going to use. And so the one that we're going to use today is called delegate. So what this method does, it will create a new delegation when we call this method. And we can see that, okay, sorry. So when we call this when the current address that we're calling it from does not have any active delegations. If we do have like an active delegation, we do not have to call this method. We can call this other method called bond more. So as you can see here, this method has 4 parameters. The first one is candidate, and the second one is amount, and the third and fourth are candidate delegation count, and then delegator delegation count. So what each parameter does? Let me just go through them really quick. What the candidate parameter is, this is the address of the collator candidate that we are going to delegate to, and the amount is the amount of tokens that we are going to delegate to this candidate. And the third and fourth are basically candidate delegation count and delegator delegation count. It just means that how many active delegations this candidate currently has, and the fourth one is how many active delegations the current delegator has. So we need to ask for this is because in substrate, these two parameters are called weight hints, and we use them to kind of estimate the gas that carrying out this method will cost. And the reason we need to know the count number is because under the hood, what this operation does is going to be, we're going to be inserting into sorted lists. And the cost of the insertion into a sorted list depends on the length of that list. And that is why we ask for these two. Let's go back to our slides again. So now that we have an understanding of the staking precompile interface, let's get straight into what we are going to be building today. So what we're going to be building today is the Delegation DAO app. So I assume that most people here already know what a DAO is. So I'm not going to spend any time explaining that. So these are some of the things that this app will be able to do. So first of all, a member of Delegation DAO can deposit their tokens into the DAO smart contract. And the second thing that this app will be able to do is that the DAO will be able to delegate the total staking pool to a pre-selected collator candidate node. And then thirdly, the DAO members can withdraw their stake from the DAO and receive the proportional amount of staking rewards from the pool. So it's fairly straightforward. So someone might ask, why would you want to stake through a DAO when you can just stake through your own wallet? So in fact, there are some reasons for why someone might want to stake through a DAO. So first of all, some members of the DAO might not have the minimum required stake. Currently, this is set to 50 Glimmer on Moonbeam. And the second reason is that members, if they stake by themselves, they might not be in the top 300 effective delegations for a given collator candidate if they stake by themselves. And then thirdly, a staking DAO can implement automated staking strategies that return higher rewards than staking individually. And then thirdly, it's possible to create a DAO-based collator candidate, where the DAO's total staking pool can be used to reach the active collator set. And that is mainly because the amount of tokens required to get into the active collator set can be fairly high. So it is unlikely for a single person to have that many tokens. And yeah, so a DAO can definitely help there. So given what we know about how Moonbeam staking works, how do we design our DAO to perform the functions that we would like it to perform? So there's more than one possible approach, but the one that I took is a state-based approach. So what that means is that the DAO will essentially track its current state, and by tracking the state, it will restrict or allow certain actions to be performed depending on what state the DAO is currently in. So let's let's take a look at the slide here, and then we'll go through every state. So the DAO can be in four possible states. One, it can be in the collecting state, which is also the initial state. In the collecting state, members can deposit their tokens, and there is no active delegation by the DAO smart contract. And in this state, the DAO will advance to the next state when the total staking pool reaches a certain threshold. And you can see the arrow linking this state to the next state, which is basically the condition that has to be met for the state to change. And the second state that the DAO can be in, and it's also kind of the main state, and I expect a real staking DAO, it will be in this state more than 99% of the time. And this state is called the staking state. And during the staking state, members can deposit tokens to increase their current share, or they can just send in tokens to when they have not had any share in the pool in the past. And secondly, an active delegation has been created by the DAO. And thirdly, the DAO will stay in this state until the scheduled revoke method is called. And then the third state is called the revoking state. And in this state, members cannot deposit any more funds. And in this state, members can attempt to withdraw. The DAO has scheduled a revoke and is currently in the delay period. And the DAO will advance to the next state when the delay period ends. And the fourth state is called revoked. And in this state, members can withdraw their tokens that they contribute to the pool. And secondly, the DAO's delegation has been revoked. And the DAO will stay in this state until the reset DAO method is called. So this state is kind of a terminal state, but we can call like a specific method to go back to the first state. So one question that some people might have is that why can we not just have every member stake and unstake as they will? Why do we need to enforce a state on the DAO itself? And the answer to that question is because this is primarily because, like I said before, on Moonbeam, the revoking action is a two-step action, which means that if the DAO does not have a clearly enforced states and an enforced way that the states flow, that it only goes one way, the DAO can be stuck in a cycle where the revoke is never executed because the revoking delay is never finished. And if it's stuck in this cycle, it is possible for the tokens to be stuck on the DAO. So that is why the approach that I took enforces the state of the DAO. All right, so let's take a closer look at our main contract for the DAO. So this is our main contract, and it's called Delegation DAO.Sol. And as you can see, it's just a standard Ethereum smart contract. And you can see here. No, sorry, that was the wrong file. Sorry, yes, here. So the smart contract is called Delegation DAO.Sol, and you can see that we use a couple of Open Zeppelin smart contract to make our life easier. And we can see the contract itself inherits from access control. And so here, so we define a couple of roles in our DAO, and so there are two roles. Yeah, so one is an admin role, and then one is a regular DAO member role. So having an admin role in a DAO is sort of a cheat. So this will ideally replace by some form of governance. But because this is only for a workshop, I use access control. So next, let's look at some of the constants and variables that we define in our smart contract. So here we see the DAO state enum, which defines the four states that we just talked about. And then the variable here is a DAO state, and the variable is called current state. So this variable will keep track of what the current state of the DAO is currently in. And next we have a mapping, which will map an address to an unsigned int, and this will track how many tokens the DAO members have sent in. And then the next, we have a variable called total stake, and this will track the sum of the stake in our DAO staking pool. And here we define the parachain staking interface. And so this is basically how we link to our precompile, our staking precompile. And as you can see, we define our staking precompile address here. And this is, we define, this is the threshold that we use to go from the collecting state to the staking state. And that state is currently set to 5 ethers. And the next variable is called target. This is the collator that this DAO is currently nominating. And then the next are just 2 events. We can take a quick look at our constructor method. For the constructor method, we take in 2 parameters. One is they're both addresses. The first address is going to be the target, and the target will be set to basically the address of the collator candidate that the DAO will nominate. And the second address is the wallet address of the DAO's admin. And in the constructor methods, we can see that we're just setting up roles, and then here we're initializing our staking precompile. So we basically use the interface object, and we set it to our staking precompile address, which is fixed. And then after this, we can just use this variable to interact with our staking precompile. And then here, this line is pretty important. At the end of our constructor method, we set the current state of the DAO to the collecting state. Okay, so next, so in this contract, the 2 main methods we need to take a look at are going to be add stake and withdraw. So first, let's take a quick look at add stake. You can see that it has this keyword called payable, which I think a fair number of people should know. What it means is that this method is able to accept tokens. So basically, we will call this method. Well, members of the DAO will call this method to send in tokens to the DAO smart contract. And as you can see here, within the method logic, there is a fair number of state checking, and that is basically checking if the DAO is currently in the correct state for this method to be called. And we can see the 2 states where the add stake method can be called is DAO staking and DAO stake collecting. And you can see the logic for when it's in each of these states. And then it will basically handle the tokens that are being sent in, and it will increment the DAO member stakes in the mapping, and then it will increment the total staking amount, and it will emit the deposit event. And so for here, when we're in the DAO collecting state, if after this member has sent in a stake, and we have passed our threshold, we will go into this block here, and in this block we will call staking.delegate, and this is the method that we looked at from the staking precompile interface, and we will basically call this method to create a new delegation. And also after this line, because we have created the new delegation, we have to change the state of the DAO from collecting to staking. So this here is pretty key to how this whole thing works when we have a state-based DAO. So a lot of it is basically checking if it's in the correct state, And when you perform certain actions, you need to change the state, change the current state. So the next method that we'll take a quick look at is withdrawal. So this method is called when a DAO member wants to withdraw their stake, withdraw the tokens that they have sent into the DAO. So kind of similarly, you have quite a few logical checks to check if the DAO is in the correct state. And if it is in the correct state, it will kind of like, it will, sorry. So the two main states that it can be in is DAO revoking and DAO revoked. So when it's in DAO revoking state, it means that the DAO is currently in the delay period between the revoke action has been scheduled, and but it has not been executed yet. So what this method will do, it will attempt to execute the staking revoke, and we see that when we carry this method, it will get the result back as a boolean. And when the boolean is true, it means that we were able to execute the revoke. And so we have a check here. If it's true, we will continue to execute our logic. And if it's not true, we will simply terminate this call, because it means that the revoking delay is not finished yet. And so here, when our DAO state is in revoked, and we will basically process it, we will process the withdrawal. And you can see that we do a bunch of math here. So the amount that we send back when a member wants to withdraw their stake is not simply how many tokens the members has sent in. The reason for that is because when they withdraw, not only do we need to return the tokens they sent in, we also need to give the member the correct amount of staking rewards that they have received. And so all the math here, it will basically compute how much staking rewards they have received. And then we can see the logic here that will basically send the correct amount of tokens to the address that the member want to withdraw to. And so the rest of the methods are fairly straightforward, so I won't really explain them in depth. Let's go back to our slides. So for the next part of our workshop, we will be using a tool called Scaffold-ETH. So I think most people should know what Scaffold-ETH is. It's a tool compilation created by Austin Griffith, and it includes like 4 major components, and it is hard hat, ether.js, the graph, and it also includes a React-based front end. And so basically, this tool is very useful for hackathons, and also for demos and MVPs, or basically anytime you want to iterate fast. And Scaffold-ETH is fully open source. It's also fully compatible with Moonbeam. So now the next part, I will deploy our smart contract, and I will also verify our smart contract with Scaffold-ETH. So this is the project that I have from here, and you can see that under the Scaffold-ETH project root folder, if you go into packages, you can see the 4 main parts. And so the first main part is hard hat, and then you can have the React app, and then this is subgraph, and then services also for the subgraph parts. So the main 2 parts that we are going to be using today are the first two parts, which is hard hat and the React app. So for the React part, we just have to add our smart contract to this folder here. So it's under packages, hard hat, and then contracts. So we add our delegation DAO.so, and we add our staking interface.so. And then the other main file we have to change is hardhat.config.js. So the main part you have to change here, you basically just have to change the default network to Moonbase Alpha, which is our test net. And this is pretty much like the only thing you have to change here, because all of our network endpoints are included in Scaffold-ETH, yeah, by default. So. Oh, and the other part you have to change is under deployment and the deployment script. And the part you have to change is here. And basically you have to pass this script the two parameters you want to use for the constructor method. And then after that, I think that's pretty much set. And we can go to our terminal. And the command we need to enter to deploy our smart contract is simply yarn deploy. And we can run the command here. So as you can see here, the contract had been compiled, and then you can see that this is the transaction hash for the contract deployment transaction. And then now we're just waiting for the transaction to be confirmed. So now here we see that the transaction has been confirmed, and this is our contract address. And we can also see this is the amount of gas that was used. And the next thing we want to do, we want to also using Scaffold-ETH, we want to verify the smart contracts. And the command we use is going to be this one. So it looks really long, but it's actually pretty straightforward. So it's yarn verify, and then dash network, and then the name of the network, and then this parameter here, we need to put in the address that we just got here. So we just paste that. Oh, sorry. Let's see. Here, and then the last two parameters, they're also the parameters that we pass to the contract constructor when we deploy the smart contract. So let's run this command here. So we can see that this is so we can see the command line is saying that this contract is being verified currently, and we're waiting for the block explorer. So the default EVM block explorer for Moonbeam is called Moonscan, and that is an official fork from Etherscan. So if you have used Etherscan before, it should be pretty familiar. Yeah. So now we see that the smart contract has been successfully verified, and we have this address here, and we can actually go on to our Explorer and then open it up. So as you can see here, this is the contract that we just deployed, and you can verify the address here, and we can see that is already been fully verified. And we can see the source code of the smart contract, and we can also read and write to the smart contract. Okay, let's go back to our slides. So next, what we're gonna do, we're also gonna use Scaffold-ETH to create a very simple front end. And let's go back to VS Code for this part. So the files that you will modify, you will need to modify here are all under this folder here, is under React app. And then so the view that I changed was example UI, and oh sorry, the two main files you need to change are, one is this main app.jsx file, and what you need to change here is basically you need to change the network to the initial network constant. You need to change it to Moonbase alpha, or whichever one that you want to deploy your smart contract to. And then we have to kind of like, depending on what your front end needs, you have to kind of write some props like here. So here I'm just writing a couple of props that will read from our smart contract. And the method we use is from ethers.js. So we use contract reader for this. And then from here, we will pass the props to our view. It should be around here. Yeah, here. Sorry, it's not here. Oh yeah, here. Yeah, so the view that we're going to use is example UI. So we pass the props that we just made to this view. And then now we look at example UI. This is basically fairly standard on ethers.js and React. So I won't spend a lot of time explaining this, but like you can check out the code on the GitHub repo. All right, so now that we have created the UI, we can launch it by going back to our command line. And then the command we need to use is simply yarn start. Sorry, it's going to take a second to load. And because we are deploying a fresh contract, so what we should see is that the total stake should be zero. So okay, so the page just loaded, and like I said before, the view we use, it was called example UI. So we just click here, and you can see this is the basic front end that I made. It shows you this is the target of the address of the collator that we're staking to, and this is we're seeing like basically showing you the state of the DAO that currently is in. We can see this is how much the total stake the DAO has, and this is what the current member stake is, depending on which address you have linked to this wallet currently. So let me connect to this one. Yeah. So we have like zero for like everything currently because we just deployed a fresh contract. So why don't we? The first thing we can do is to add some stake. Let me just to kind of make it. Let me add 5 because that is the amount. That is the minimum amount of staking requires, and that is also the amount that will push our DAO state from collecting to staking. So we put 5 here, and then we press this button here. And then now we have a MetaMask pop up, and we can sign our transaction. You can see that we are interacting with our smart contract here. So we have to wait a second for our transaction to confirm. And once it confirms, we should see that the interface will automatically update and show us what the new total stake is, and it should also show us what the new DAO state is. Okay, so now that we see our transaction confirmed, we see our total stake is 5 because we just put in 5, and then our member stake is also 5 because I'm currently connecting the wallet that I use to add stake, and I'm the only person who is in the pool currently. So the total stake and member stake are the same. And we see, like I said before, the current DAO state, it changed from collecting to staking because 5 was also our threshold that will make the DAO go from the collecting state to the staking state. And for the next step, let's call a schedule revoke. So when we schedule revoke, it will take our DAO to the next state. So let me just give it a little bit more gas. Yeah, let's go high. So for this change, we will just, I think we should only see the current DAO state change. After the transaction confirms, we should see the DAO state change from staking to revoking. And but because, like I said before, because of how staking works on Moonbeam, um, on our testnet, the revoking delay period is 4 hours, which is too long for us to wait. So what I will show you guys to finish the last step is I will show you an instance of this contract that I deployed last night, where I put it into this state, but the delay period would have been passed. So you can see the contract state changed. So yeah, so let's do the final step here. So this is an instance of the same contract that I deployed last night, and it should be in the third state. Sorry. So as you can see here, it should be, the current state is 2, because it goes from 0, 1, 2, so it is in the third state, and the total stake is also 5. And let me just withdraw from this wallet from this DAO. So I want to withdraw to my address. So I will copy and paste my address here. And I will call the withdraw function here. I will give it a little bit more gas. Okay. So we see, once this transaction confirms, we should see that the 5 dev or like ether that we put on the DAO should be returned to this address. So yeah, we see that the transaction has just been confirmed, and our wallet balance increased by 5. And we can also check our smart contract here to make sure we're in the correct state. So because I just finished revoking, the current state should have changed from 2 to 3. So we see, yeah. So we see that now the current state is in the fourth state, which is the revoke state. And we should see the total stake on this contract should be now 0. So yeah, and then we see that it is 0. So we were able to withdraw the tokens that we place into the DAO back to our own wallet again. So yeah, let's go back to our slides again. So that is the end of the workshop. Let me know if you guys have any questions. Here's our ways to get in touch if you want to find out more about Moonbeam. And you can also scan the QR code to join our Discord. And yeah, thank you guys very much for your time. And hope you guys join in for our hackathon. Yeah.
Awesome. Let's see if there's any questions. I am not seeing any questions in Q&A. So if anyone has any questions for Henry, just go ahead and just enter them in the Q&A there, and he can go ahead and answer them now. All right. Well, I'm not seeing any questions. I think, Henry, you did such a good job at explaining everything. No one has any questions. So I think we'll go ahead and end the session. So I do want to thank you, Henry, for a great session, very comprehensive. And thank you, everyone, for joining. Just want to let you know that we have another workshop coming up right after this one from Anir about how to write a smart contract in JavaScript. I'll close this session, and then you are welcome to join the next one with the same link you joined this one. So thank you again, Henry, and thank you, everyone, and we'll see you on the next one. Bye.
All right, thanks. Bye-bye.